All right, guys, we're going to go through chapter 20, and chapter 20 is all about conventional energy alternatives. So there's a couple of things that you should know list-wise with alternatives. And one, obviously, is know the difference between energy and electricity. So energy is everything we use for energy, for transportation, for heating, for cooking, for electricity. And electricity is just electricity. But anyway, so when we look at the world's energy, oil is the most leading that's used, then coal, natural gas, then biomass. And again, energy includes electricity. But if we're looking just at electricity, the king of that would be coal. And then natural gas, hydroelectric follows that up. And then nuclear is the next big one. So you can take a look at all of those. Nuclear power in the United States produces the most amount of, the United States produces the most nuclear power. However, we don't think about it as, we only produce like 20% of our electricity with it. But because we are a large nation, we do produce a lot of power in general. But you can take a look at some of the actual measurements and everything else of how much of our stuff actually is nuclear. And eventually, though, we look at France, and France is number 2, but leads the world in nuclear power because it actually makes up the highest amount of their power at 75%. They do have a lot of wind power as well in there, but a lot goes into that. So what is nuclear power? Nuclear fission is the splitting of uranium-235. We bombard it with neutrons to split it in half into other atoms. And in the process of splitting, it releases a lot of energy. And that energy is released in the form of heat. That heat is then used the same way that like a coal power plant would do it. And it heats up water to create steam to then turn a turbine. So you need to know that uranium-235 basically causes a chain reaction of positive feedback. And as we take a look at that positive feedback, more and more energy is then produced. So there's actually a diagram of the nuclear power plant that's right down here. And if you don't understand it, make sure you take a look at that further with the steps that are down here. But it shows nuclear rods that keep basically reacting, and eventually that reaction runs out, and we call those spent rods. But in the meantime, they're going to continue to release energy. The water can be reused then. It actually goes through a cooling loop, or can actually be released through a tower, but it has to be pulled down. And then sometimes we can cool it using a body of water like a lake or a river. We call that process, just cooling down the actual water. Unfortunately, it does produce thermal pollution. So uranium is something that's interesting. We get uranium, we mine it in the form of 238. It comes out of the ground in Nevada. It's mined originally by like the Navajos. We have to enrich it to 235. So we make it into these small little pellets, and then we use those in the fuel rods. So the fuel rods are stored in water to prevent explosions. And the biggest problem with the Fukushima reactor was when the tsunami happened, it actually took out the pumps that kept replacing the warm water with the cool water in the reactor, and the core started to heat up too high. And unfortunately, that's what caused the biggest issue. Also, a lot of this stuff is contained in cement and steel walls to reduce the amount of leaks that could be occurring. So again, steel, cement walls. And it also tries to prevent anything that might leak if there was an earthquake to occur. So with anything that's radioactive, you do need to understand half-life. And half-life is really important for us to get. Remember, this is a review, and it's the time that it's going to take for half of an atom to give off the radiation or decay. So the half-life of uranium-235 is 700 million years, which is a huge problem because this stuff is going to stay radioactive for a long period of time. Some of the other big things that we have issues with is that these rods need to be stored during that time. And again, possible things for nuclear power to continue to use it is to continue to use it until we find a better alternative so that we're not having to use all this stuff that's going to create radiation and everything else. But the positives are that it produces no air pollution or greenhouse emission if we catch that water vapor. So nuclear fusion, which is actually highlighted down in here, this is how we get energy from the sun. So fusion is highlighted down in that area. It's the power the sun takes on. So basically the sun will take atoms and fuse them together. So two hydrogens fuse together to make helium. We don't know how to do this yet. If we did, we would definitely have all the energy we would ever need for the planet. But we're trying. We haven't gotten really there yet. Some of the big things that you should know as well are some of the biggest nuclear problems that we've had in the last, centuries. So we have the 3 Mile Island, we have Chernobyl, Fukushima. All these cases were accidents or natural disasters that led to the release of radiation. And you should know a little bit about what's going on short and long term with those impacts as we go through things. So I'm just going to highlight this one over here. And again, these next few pages go through each of them separately, so you might want to take a look at those. So 3 Mile Island was in the U.S. It was in the east in Pennsylvania. And there was a meltdown that occurred at this particular plant. The official word is that there weren't any deaths, but there were some evidence 30 years later, like right now, of higher rates of thyroid cancer in that population. Chernobyl was in the Ukraine in 1980s, and that explosion created a lot of radiation that spread all over Europe, and that basically spread due to the wind. So you can see some of the places that were actually affected because of that. It was random. It basically spread that radiation in the direction that the wind was blowing. So this map does show some of the radiation that went wrong with that. In Japan, in the 2011, the Fukushima, that was an earthquake that occurred in Japan, and that caused a subsequent tsunami. That tsunami knocked out the generators. They couldn't cool down the plant, and it actually caused explosions and a lot of radiation exposure. So again, you can see the tsunami wave coming up in here. Here's some cooling areas, and that kind of shut that all down. This was basically caused by the fact that there was convergent plate boundaries happening, and we know Japan has quite a bit of plate tectonics going on there. And the ocean, which was more dense, slid underneath the continent, and that caused then the displacement of water, which made the tsunami. So you do need to know that radiation causes specifically thyroid cancer, and this would be located more in your throat area. Spent fuel rods are a big concern right now. You can actually see some of the storage in the facilities in this picture. So now we store them on site at the locations of the power plant. Long-term storage is hopefully by Congress going to get planned out soon, but it's going to be in Yucca Mountain, Nevada, because this is a place where there's there's not a large population center. It's close to a mountain that's not seismically active, at least currently. And we can store it deep underground in tunnels. So there's been definitive plans put in place, or there has not been anything crazy going through, but they've been trying to plan this out for years to come. Unfortunately, there's a lot of pushback because people in Nevada don't even use nuclear power, and they're being asked to store basically all the country's waste during that time. They don't really like that thought. So it's not currently occurring, but the plans are there. The next big thing is biomass, and there are some examples here of different things for biomass. So biomass bioenergy has a lot of sources that you can see again in this list. It comes from anything living that we can burn, and that would be considered biomass energy. So cow patties, trees, logs, burned for fuel, for cooking, anything along those lines. In the US, we use corn for ethanol, and other countries use sugarcane. We also use spent oil from restaurants, and that, was previously fat tissues from other things. We also basically need to look at the fact that this doesn't give us as much energy as coal. Coal definitely has more energy stored within its bonds, but it's a better alternative for different reasons. So if we take a look again, it produces heat at a low price. It's going to produce some negatives though. So CO2, carbon monoxide, VOCs, particulates, nitrogen oxide. So whatever you'd get normally when you would burn something. And over harvesting of trees for fuel can actually cause deforestation. So there's some negatives that do go along with it. So as we start to look at some other stuff, Biomass that's used for automobiles is called biofuel. And ethanol is the best known one of the biofuels that we typically hear about, and it comes from corn in the US. You can buy a flex fuel vehicle that runs on E85. So basically that means it runs on 85% ethanol and 15% gasoline. We see those mainly in the Midwest, a lot out on the East and West Coast. They don't typically sell those cars as much because their capacity to get to some of this ethanol is a lot lower than we have in the Midwest. The problem with ethanol is that it's driving the price of food up due to the fact that we are competing with the fuel source for the corn. We're also competing with the crops that are needed to feed our animals as well as humans. So it's going to drive that price of food up. People say we could just, grow more corn and save the environment. But the problem is that we don't actually have enough land to do that. And it really doesn't save us much in carbon dioxide emissions or air pollution, because when you grow corn, you use a lot of fossil fuels for the pesticides, the production, and other things from the farm machinery. So there are a few other places like Brazil that instead of growing corn, they grow sugarcane for their biofuels. And biofuels are not seen everywhere again, but mainly in the Midwest. So you have some positives and negatives in here. Again, it is a substitute. We're not introducing new carbon dioxide in the air. We're introducing stuff that's already been trapped within the plants. But unfortunately, the energy return on investment isn't as high. One of the other issues with ethanol is that we don't, again, have enough corn to replace gasoline completely. So that's a bigger issue as well. We don't have enough land available. And again, we need that food supply for our animals and ourselves. So biodiesel can be made from used cooking oil as well. And we can pick up restaurants oil, like from the fryers. It has less emissions. It's non-toxic, biodegradable, and it makes your car smell kind of like French fries. I used to drive to work behind a car that would say like fueled by, cooking oil. And it did. It smelled like what you would expect, like a deep fryer making fries. So you could do this. You can actually buy converters and conversion kits to turn your engine over to do this. Loyola University Chicago has a fleet of trucks that are done with this biodiesel, and the restaurants are actually happy to give it away because they have to try to find a company that's going to dispose of this oil some way. So if you're willing to take it off their hands, they're more than willing to probably give it over to you for little to no price. An alternative to this is algae, and algae is being used as an experimental source. There's actually a lot of commercials out right now with algae, and you can take a look at that picture right here. But algae is being experimented as a potential biofuel. You can grow it pretty easily. And the nice thing is while it's growing, it's taking in CO2. So it's a win-win. And it can also be used as obviously the fuel. So hopefully we're able to actually use this more. It is expensive, so they're trying to make it more cost effective. And hopefully in the future they can do this. There's another option out there, and that's up here. And in Wisconsin and Michigan, we're toying with this more. And it's something called switchgrass. So switchgrass is another type of plant to maybe replace corn because it grows quickly. You can actually harvest it more than one time in a year. It's kind of a cover crop too, so it doesn't require as much work or pesticides or fertilizers. So it's a better crop for the environment. And they're trying to see if we can actually use that to replace some of the ethanol that's produced by corn. Hydroelectric power, if we take a look at hydroelectric power in here, it provides electricity using the movement of water. So once the dam's created and paid off, it's actually really cheap electricity because everything is already there and nothing needs to be mined. So there's no overhead later on in the lifetime of this. There's not something that needs to be consistently mined to actually keep the production going. So we force water through turbines. So if you take a look here, we've got water going through the reservoir in the back. And again, it goes from the potential energy to kinetic energy. And when that happens, it turns the turbine, which then powers the generator and creates electricity. And as long as you have water in the reservoir, you should have power that's being created. So there's nothing that greenhouse emission wise, there's no greenhouse emissions. There's little air pollution, none. Another type of energy can be created actually using running rivers as well. So if you have, maybe this is your house and you're living kind of off grid. If you have a creek or a running river that's near you, you can actually take energy from that and push it through pipes. And as it's pushed through pipes, it increases the pressure and it then goes through a smaller generator and or turbine, I'm sorry, and then generator is produced. So this is more small scale, and you can use that for a house. Some of the issues, unfortunately, are that we can't basically expand in the US anymore on hydroelectric power. Anything that's been dammed has been dammed. So we have no available sites to dam up anymore. Also, in tropical regions, tropical countries, the reservoirs, if they sit there too long, and this is a smaller pond or smaller lake, can actually cause for a mosquito breeding ground. So you're going to see an increase in yellow fever or Zika and other diseases that are transmitted by different vectors. So we have to be careful about that. New dams, again, also release methane due to the fact that you could be reflooding nice land back here, and that's going to start to decompose, and that will give off methane, which we know is a greenhouse gas. So we have to be careful with that as well.